Okay, previous class we stopped at the whiteboard with the exercise. Anyone proceed with the exercise? Okay, great. Okay, question 1, it asks you to illustrate, illustrate the cellular respiration diagram which shows the overall flow with correct labeling. Okay, with correct labeling. So this is the cellular respiration. Okay, the keyword over here, cellular respiration, because we have fermentation as well. Now it is asked to do cellular respiration. So this is the diagram. Where it involves the Krebs cycle. Okay, so it involves the Krebs cycle over here. Krebs cycle, then moving forward to electron stage, electron transport stage. Okay, so for the correct labeling here means, correct labeling. So you must do the correct labeling on where, what is this part. Okay, glycolysis, it involves the glucose. Okay, involve the glucose part. Then proceed to pyruvic acid or pyruvate. Okay, then it involves the release of NADH. Are you in the Teams? Are you in the Teams? No. What's your name? Let me add you to the team. Your name? Huh? W. Wang Jianming. Okay. Okay, so this is the correct labeling, pyruvic acid or pyruvate. Then moving forward to the acetyl CoA, which involve the Krebs cycle. Okay, this one you must label acetyl CoA and the Krebs cycles. This part, it releases the NADH. Okay. Then it move forward to the electron transport, etc. So here you will see there are 3 stages. There are 3 stages. Stage 1, glucose convert to pyruvate. Then stage 2 would be the Krebs cycles. Then stage 3 will be the ETC. Okay, another thing that I would like to see is the products produced, which is the CO2, ATP. Okay, then in ETC, the electron transport stage, it involves O2 into the process. It uses up the O2 and produce the H2O. Okay, this part. Okay. So the correct labeling will bring marks. In this question, it asks you to illustrate the diagram. It doesn't ask you to explain. So this answer is sufficient. Otherwise, unless the question asks you to explain with diagram, then you should include the diagram with the explanation. Okay, can I? For question 2, identify the two types of metabolism. So this one refers to the, what is it? Catabolism and anabolism. So here you should, okay, even though the question is identified, wait, we'll make it bigger. Okay, even though the question here mentioned identify, and it brings 6 marks. That means you need to identify the type of metabolism, not only giving the name of catabolism and anabolism. You should put some description. What is catabolism and what is anabolism? Okay. The keyword is the whether it produce energy or use up the energy. Okay, any question? This one is midterm, previous semester midterm. The midterm I will announce on next week when will be the date. Okay. Since the midterm should cover CLO2 and 3. Sorry, 1, 2. CLO1 starts from this chapter. So we should finish up the chapter first. Okay, any question on this? Okay, moving forward to the next subtopic, which is the stoichiometric of microbial growth. Now it will involve some calculation. Okay, here we will learn about the microbial growth and the product formation. Okay, for the growth, this diagram is a common diagram to the bacterial growth where it involves few stages: the light phase, the growth phase, stationary phase, and the death phase. Okay, so in order to produce this diagram, you will need some data of it. Okay. Now, this subtopic will cover the overall growth, stoichiometry, and design medium formulation. how much of your substrate required to produce the required product. Okay, then the third calculation of elemental balance and degree of reduction. These all are just a simple calculation, but then you need to grasp the important infos. Okay. So the third one will be the theoretical prediction of yield coefficient. Yield coefficient here, you will have few types. Yield based on the substrate, yield based on the oxygen, yield based on the ATP. Okay, there are few types. Now, these are the terminologies that you will come across later on. YXS. X always refer to biomass. Okay, the S is always refer to substrate. So this one, the yield of biomass from substrate, your product. Biomass here means the amount of the cell produced after the process. Now this one is the yield of biomass from oxygen, according to the oxygen. There are two different things. Okay, so from the substrate, how much is the yield? From the oxygen that you supply, how much that you get for the biomass? Okay, so YPSP is the product based on the substrate. Product here, for example, perhaps ethanol. So based on the substrate used, how much is ethanol produced? YPX product based on the biomass. Then YCS, C is the CO2. Okay, mass or mole of CO2 produced per unit mass of substrate. Okay, so there are many infos that you will need to focus on. YX ATP is the biomass produced based on the ATP used. Okay. Now for the bioprocess to proceed, you will need microbes and also the substrate. Okay, that is important. The most important things lah. Of course, you need the microbe and the substrate. So in the process, okay, this is the process. Microbe, which is the cell, plus the substrate, the medium. Medium here, it can be any kind of medium. Perhaps glucose or any suitable medium. Okay, so from here, there are parameters that you need to monitor in order for your microbe to grow. Okay, why it is important for your microbe to grow? Why it is important for your microbe to grow? Microbe inside here, so there are parameters that you need to monitor in order to make sure your microbe grow well. Why you need to take care of the microbe? To avoid what? The bad impact. Other than that, to resistive to high temperature. Okay, the temperature is one of the parameters that you need to monitor. But why? Sorry. Temperature. But why you need to monitor the growth of the cell? what will happen if the cell is not growing? Huh? It will die. So if it die, what will happen? Huh? The process won't occur. So there will be no product. Okay, the important here is the microbe is the one that will help to produce the product. So if you don't take care of the microbe, it won't produce the product that you need. So that's why it is important for us to take care of the microbe to make sure the microbe grow well, because it will consume the substrate. Consume the substrate, then it will react and produce the product that you require. Okay, for example, production of bioethanol, it used from sugar in fermentation process, right? Sugar is the substrate. The microbe is the Saccharomyces. That is the microbe. So it needs the microbe to convert the sugar into bioethanol. If the microbe doesn't grow, die, so the sugar will not be converted to bioethanol, right? So that's why it is important for you to monitor the microbe growth. When it involves the microbe, it is very important to monitor the growth. So the growth is based on the temperature, the DO, dissolved oxygen, if it requires aerobic process, DO. If it requires anaerobic process, which is without the oxygen, you will still need to monitor, because you do not want oxygen to be in your process. Should not be oxygen for anaerobic. Okay? Because that microbe do not require oxygen to produce. What happens if microbe anaerobic process, but there is oxygen inside? What do you think will happen? Process spoil. Yes, one of the effect, the process will not occur according to your setup, according to your condition. Then it perhaps might produce different type of product. Okay, because you already changed the condition to aerobic. And then perhaps in that microbe colony, there is other types of microbe that will dominate the reaction, which use the oxygen, and it will produce different type of product. Okay. And we have the microbe that virus might produce. Correct. Yes. Same thing. Vice versa. If the process requires aerobic, but then no oxygen being supplied, so different type of product will produce, and perhaps different type of microbe will be dominant. Because sometimes in the microbe, you might have some other types of microbes. Yes, microbe is very sensitive. Once it dies, then you need to start all over again. Last time during my PhD time, there was one student dealing with microbes. I think biogas production from animal waste. The bioreactor, it needs to run every day, daily. Okay, and the mixing process, the temperature, everything. But the lab, unfortunately, it always black out. So the microbe die. You imagine how many times she need to repeat the same thing. Disaster. Okay, so that's why it's important to monitor the growth of the microbe. So the parameter, temperature, DO, the pH, nutrient, and the last thing is the degree of mixing. Okay, so those 5 are the parameters that should be monitored for the cell growth. Okay. Now this one example shows the growth parameters of some organism growing anaerobically, okay, without oxygen in a chemostat. So there are various of organism, various of microbe. Then the growth limiting factor means it requires this component in order to grow. So the system, it should monitor the glucose composition, glucose volume for this kind of organism. Okay, this is the M. M is the rate of ATP consumption for maintenance energy. So it uses up this amount of ATP. Okay, why X ATP just now? X is what? Biomass. Biomass per ATP use. Okay, this one X over ATP. So biomass per ATP use. M over here is maximum value. Okay, maximum value. So these are the maximum value. Whereby if you don't see the M up here, that means that is not the maximum value. It is the collective data. Collective data. So it doesn't mean that data is maximum data. Okay. Okay, can I? ATP is the energy consumed. Substrate over here, what is the substrate? Glucose, yes. The growth limiting factor, that is the substrate. Okay. Substrate is the nutrient. They can have a mix of nutrients. For example, here you can see the growth medium, mix of nutrients. So for example, the first one, the growth medium, this is the growth medium, but this is the growth limiting factor, the important factor. Okay. Okay, now I proceed to the next slide. This is how to estimate the biomass. Total mass and number of atoms of each element are constant in all chemical and biochemical reactions. Okay, the estimation of biomass can be done by using stoichiometric calculation with the help of these two things, biomass yield and product yield. Okay, there are two types of stoichiometric calculation, whether from elemental balance or degree of reduction. Okay, degree of reduction here, it involves the valence electron, everything. Okay, now we go one by one. In the reaction, we will have substrates, product, and cellular material. Okay, this cellular material is the biomass, the X part. A typical cellular composition can represent by this. This is the general biomass equation. Okay, cellular refers to biomass. Okay, 1 mole of biological material is defined as the amount containing 1 gram of carbon, such as this. So all of H, O, and N in your cell material will be What's the term? Will be based on the carbon. Carbon here always 1, C1. Okay. Now, this one is the example of the reaction where 1 mole of carbohydrate means, for example, the glucose. Okay. It needs O2 for aerobic process and H3. So we'll produce this biomass. This is the biomass produced. Okay, this mole of biomass, C mole of biomass, plus water plus CO2. Okay, this one, provided there is no extracellular products. Okay, we can proceed with this equation. Only H2O and CO2. Okay, this is as you can see over here, different types of organisms have different cellular composition. This is the composition. Okay. Now, bacteria, aerobacter, you can see the different. No worries, in midterm or final exam, this one will be given. Okay, you don't need to calculate. Or perhaps this table will be given and it mentioned, let's say, the system involve Candida utilis. Okay, so you should extract all infos from here. You have the chemical formula and the formula molecular weight. Okay, who take fuel and combustion? No one here. Okay. In fuel and combustion, there is the first chapter will be teach about how to come up with the chemical formula. Okay, all will be based on the carbon, similar to this. Okay. Okay, this one, simple elemental balance on C, H, and O, and yield the following equation. Okay, you are now year 3 and year 4 already, right? So you should know how to balance the equation already, correct? Okay, I don't need to go into details on this balancing the equation. Now for C, there are few unknowns over here. We need to balance up the equation in order for you to identify the unknown. Okay, here, balance the C, this one, right hand side, left hand side. You will have a few of equation over here. The unknown. Okay, this part know how it gets. H M plus 3B equals to alpha multiplied by C plus 2D. Okay, so that's how it gets the unknown for each of the atom. Okay, balance all atom. Nitrogen, so B, C, and delta. Okay, so that's how it get over here. Now the next term is the respiratory quotient. This quotient is to indicate the metabolic state and can be used in the process control. Okay, some of the stoic, it will ask you what is the respiratory quotient. Okay, respiratory quotient, it involves the mole of CO2 produced per mole O2 consumed. So the CO2 over O2. E, the mole of CO2, okay, the E over mole of O2. You will get a figure for the respiratory quotient. So from there, you will know how much CO2 is being produced. Okay, up to there, any question? Okay, I proceed to the degree of reduction, where the degree of the reduction equivalents to the available electron per gram atom C. Atom C, not the whole component. Okay, let's say glucose, it has C6H12O6. So the degree of reduction is the available electron per gram atom C only. Okay, it is the available electrons, those that would be transferred to oxygen upon oxidation of the compound. Okay, this one involved in the stage of the ETC, in the glycolysis process. Degree of reduction for some key elements are this figure. Okay, this one actually, the valence electron of each atom. This is the valence electron. Okay, that's why it involved in the ETC process. It transferred the electron to the NADH, remember? Okay, so the valence electron, it involved the valence electron. Okay, we do some examples so that you understand further. Now, for this example, 4 is the valence of carbon in CO2. CO2 consists of C and O. Valence electron for C is 4. Valence electron for O, what is it? Valence. -2. Valence electron. Okay, and then -3 is the valence of N. Okay. Now, it asks you to calculate the degree of reduction for substrate. Okay, substrates here given as methane, glucose, and ethanol. Degree of reduction. Okay, remember again, I go back to the previous slide. Available electrons per gram atom C. C. This is the available electron per carbon. Okay, per carbon. Okay, so for methane, it involves C and H. Okay, we find out what is the available electron. So 1 here refers to 1 carbon multiplied by the valence electron of carbon. This is the valence electron of carbon. Okay, 4 plus 4 of the hydrogen multiplied by the valence electron of the hydrogen. 1. Okay, so that's how it gets the 8. Now, using the total electron over here, we can calculate the degree of reduction. So what 8 over number of carbon. Here carbon is 1, so divide by 1. So that's how you get degree of reduction for methane is equal to 8. Okay. Per carbon, yes. Okay, that one is for methane. If you have glucose, again, you need to find the number of electron involved. Okay, by including valence electron of the carbon. Okay, this is for carbon side. 6 carbon multiplied by 4. Then this is hydrogen. You have 12 hydrogen. Then this is for oxygen. Okay, calculate all together, you will get 24 electron. Divide by the number of carbon that you have. Here you have 6. So that's why divide by 6. Then you will get the degree of reduction for glucose is 4. Okay, it involves simple calculation, but then you should know which value to be used. Okay, so for ethanol, you will get 6. Okay, any question? This table shows you some example of degree of reduction for few components. Okay, so from here you can see the degree of reduction, meaning that the higher the value, the high degree of the reduction. Okay. Okay, let's see. This one, we consider aerobic production of single extracellular product. Extracellular. That means you have other type of product apart from H2O and CO2. Now this is the product. This is the biomass. Biomass is X, P. Okay. Substrate always denote as S. Now to find out the degree of reduction for all substrate, biomass and product, this is degree of reduction of substrate. So substrate, it involves C, H, and O. Again, we need to find out the electron valence for all of it. Number of electron. How it get 4 over here? This is for C, H, and O. Okay, so here 4 is because 1 carbon multiplied by 4 valence electron. Plus M is for the H. 1 hydrogen. Sorry, M hydrogen multiplied by 1. Valence of electron for hydrogen is 1. Then minus here, -2 over here is the valence electron for oxygen. something like this, n multiplied by -2. Okay, that's how it get this equation. That is the degree of reduction for substrate. Similar concept to find out the degree of reduction for biomass. Okay, this is the biomass. Carbon, 1 carbon multiplied by 4. Consider only the biomass molecular formula. The C over here is the number of biomass produced, the mole of biomass produced. Okay, so in calculating the degree of reduction, mole of the biomass produced can be ignored. Okay, so here, this is the carbon, hydrogen, oxygen, and nitrogen. Same goes for the product where it involves the C, H, O, and N. Okay, so those all are unknowns. Do the balance for C balance, N balance, then include in with the electron balance. Okay, so from there, you can find out your unknown. This one, left, right. Okay, C of biomass. See here the mole of biomass plus mole of product equals to substrate. Negative 4A. Where comes this negative 4A? YS is the substrate over here. YS. Negative 4A. Oxygen, yes, correct. Valence electron for oxygen. 2. Okay, here. Here is 2 multiplied by valence electron of oxygen, then multiplied by A. Okay, so I introduce first how to get the equation and everything. Balance the equation in order to find out your unknown. Now we try to do this example. Assume the experimental measurement for a certain organism have shown that cells can convert 2/3 of the substrate carbon to biomass. Okay, this is a big info. The cell can convert 2/3 of substrate to biomass. So another 1/3. That means from substrate, okay, for example here, the first one. Which one is the substrate? You need to identify first which one is the substrate. Yeah? The hexadecane, which one? This one, right? This is the substrate. Now, which one is biomass? Correct. This is the biomass. The product, not product, biomass. Okay. Now here it mentioned cell can convert 2/3 of the substrate to biomass. So this biomass comes from 2/3 of substrate. Okay. Now that is the info, because later on you will need this in your calculation. For the second equation, this is the substrate glucose and this is the biomass. Okay, so question number 1, it asks you to calculate the stoichiometric coefficient for the biological reaction using hexadecane and glucose. We go one by one. Now for hexadecane, from the statement just now, amount of carbon in 1 mole of substrate. This is the substrate. Amount of carbon. We have 16 carbon. Multiply by the molecular weight of carbon, then you will get this figure in substrate. Okay, now we are focusing on the carbon only. This one in substrate. So amount of carbon converted to biomass. Here, converted to biomass. We focus on the carbon. Now from the statement just now, it is 2/3 from substrate convert into biomass. So we can use that statement. The carbon in the biomass is 2/3 from the substrate. This is substrate. Multiply by 2/3, so you will get carbon in the biomass. Okay, that one we focus on carbon. 2/3 convert into biomass. Where goes the 1/3 of carbon from the substrate? Two-thirds of carbon go to biomass. 2/3. Where is the rest of 1/3 of the carbon? Yes, correct. The 1/3 goes to C in CO2. Okay, this one we are focusing on the C only, so that you can understand. Okay, so from there, then using the infos on the carbon converted to biomass over here, we can calculate. That means the whole thing over here equals to 1 to 8. Okay, 1 to 8 on the biomass. 4.4 the carbon multiplied by C, the amount of the mole of the biomass, multiplied by number of carbon, multiplied by molecular weight of carbon. 4.4 number of carbon in biomass. Okay, C is the mole over here. Now from here, one unknown, which is the C. So you can calculate to find out what is the C. Okay, so you will do the calculation and C is 2.42. Okay, all this is to find the unknowns, the A, B, C, D, and E. Okay. Now after that, C already know. Now we move forward using the infos of CO2. Amount of carbon converted to CO2. 192 is the amount from substrate. C substrate minus C biomass. So you will get C from CO2. Okay, so this is your C of CO2. If you plus back the C from CO2 plus the biomass, you will get the substrate back, the original one. Okay, so here C substrate is equivalent to biomass plus CO2. Okay, the C substrate which is 192. C biomass is 128. This one is 64. Okay, this is 2/3. This is 1/3. It's either you minus up or you can recalculate from the 192 multiplied by 1/3. Same thing. Okay, now from there, we know that E CO2 is equivalent to 64. This whole thing is 64. Okay, so from here, E multiplied by molecular weight. Sorry, not whole thing, the C only, sorry. Not whole thing, the C only. Amount of carbon equals to 64. E multiplied by molecular weight of the carbon. Then you will get the unknown E. Okay, so now E already get the value. E get the value. So you can use the nitrogen balance to calculate the B. (14) here refers to N over here. Molecular weight of the N. This is molecular weight of N. Okay, C we have calculated earlier. 0.86 refers to the N over here. Multiplied by molecular weight of nitrogen. So you will get B. Okay, similar concept, similar method to find out the rest of the unknown. D using hydrogen balance. A using oxygen balance. Okay, all of this is to find out the unknowns. Do the balance. Base, okay, it starts from the amount of the carbon from the statement. Okay. So once you get all the unknowns, this is the equation that you are looking for. Stoichiometric equation. Any question? Simple calculation, but then you will need to know how to start, which infos to extract. Okay. Now, same thing for the glucose. This one is for glucose. Similar step. Find the amount of carbon in the substrate. Then in biomass. Then find out the unknowns by doing the math. Okay. Okay, this one to calculate the yield coefficient. Yield coefficient y-axis. X based on the substrate and X based on the O2. Okay, two different value. Now, for the hexadecane, y-axis. X is the biomass. The biomass from the previous equation. This is from the previous equation. Okay, we already know the unknown. So, 242 multiplied by the molecular weight of the biomass. How to get molecular weight of biomass? Can I absorb? How to get molecular weight of biomass? Come again? Huh? Sum up all the elements. C, molecular weight of the C, molecular weight of the H, N, and O. Then you will get the molecular weight of the whole biomass. Okay, so divide by molecular weight of the substrate. Substrate here is the hexadecane. So sum up all together. 16 multiplied by 12 plus 34 multiplied by 1. You will get this figure. So this is the amount of y-axis. 0.98 GDW. What is this? DW stand for dry weight, correct? Dry weight over gram substrate. Okay. Now same thing for the Y biomass per oxygen. So biomass over molecular weight of the oxygen. Okay, oxygen over here, this part. Okay, so you will get this figure. Same thing for glucose. Biomass. Okay, mole of biomass multiplied by molecular weight of the biomass divided by molecular weight of the substrate. Okay. Make sure you take the correct value over here. Per substrate or per O2. Okay. Okay, a bit more, Okay, this one is similar things. This one, YXS equals to YX ATP N. So this one is based on the ATP produced. Okay, so it depends to the value that will be given for the ATP. Okay. Similar concepts. CO2 per S, so amount of CO2 over substrate. P over S, so product over substrate. You just extract the correct value. Okay, so that's all for this subtopic. Next class, we will do some exercise so that you can understand further. Okay? Okay, that's all for today's class. Oh, sorry. Okay, thank you, class. Chapter 2 finish, yes. Next class, we'll do